Hi students, welcome back to my YouTube channel SADHIK Physics, where we can learn the physics very easily. So now new topic we are going to discuss, that is current electricity, right? So very important chapter no. So current electricity, in this video we will discuss only purely so what is mean by current no, therefore so how to calculate the current. Already you know it, you might have studied in lower classes also. So but let us see some different questions also we can discuss onto this, right? So current means what is mean by current no, right? You might have seen like so many times you might have heard like a river current and air current, electrical current, like that no. So you might have seen no, the current means flow, clear? So therefore here we are discussing for electricity, so therefore current electricity we can discuss now, clear? So therefore here current, therefore see how the charges will flow. Current means nothing but here flow of charges now. So river current means flow of water, air current means what? Flow of air, okay? So how that air will flow now, right? So air will flow is because of due to pressure difference. So from always from high pressure region to low pressure region, always the wind will flow or air will flow now, clear? So water current means it is always flow from higher potential region to lower potential region now, clear? So therefore compulsory the potential difference, potential energy difference no is required no. So then it will be able to flow, right? The current it will be flow. Even temperature also, I mean heat also will flow is because of due to the temperature difference now. Here current, the flow of charges no, it will flow from higher potential region to lower potential region now, right? So you might have seen the battery or a generator no, what it will create it no, the battery, right? Therefore here we will go for only direct current no, therefore direct current will be given by the batteries. So therefore so the battery what it will do no, it will provide a potential difference no. So two terminals will be there, one is positive terminal and negative terminal no. Positive terminal treated to be like a higher potential and negative terminal is nothing but a lower potential. If you connect with one wire, so through that wire no, therefore the charges will flow. The rate of flow of charges only we will call it as electric current now, clear? So like our river is there no, the water is flowing through the river only, yes and that river part is there no, therefore is nothing but like our wire. So it is started from higher region to lower region means, so that is said to be like a higher potential region where it is reaching to the end point no, that is nothing but a lower potential region. If there is a flat is there no, if suppose a river which is having the flat, so the water will not flow, will stay there only, compulsory the potential difference is required. Suppose if there is a flat is there, the water will be stay here no, so it will, if you slightly tilt it no, this is higher potential, this is a lower potential, definitely the water will flow here no, clear? So I think you understood no, therefore so what is mean by this current no, right? So here we can go for electric current. So electric current, so electric means what? We can know that it is a charges no, current, therefore current is defined as like a rate of flow of charges. What is meant by the definition of this one no? A rate of flow of charges, clear? So the rate of flow of charges no is nothing but the current no, therefore current can be defined as like a dq by dt, or the net charge which is flowing by in time no, or a total charge by time. Therefore this all are nothing but it is the same only. So this is an instantaneous current no, therefore here this is a constant current, therefore what is the unit now? So this is coulombs per second, 1 coulomb of charges in flown in 1 second is said to be like a 1 ampere. 1 ampere is a fundamental quantity, therefore dimensional formula for this one now only the ampere itself, because current is nothing but a fundamental quantity now, clear? So now is a vector or scalar? definitely it is a scalar. You can tell that, sir, current is having a direction also, it will move from always positive to negative. So, and it is also magnitude also is there, even though magnitude and direction is there. So, therefore, it is treated to be like a scalar only. Why? Because so vector definition is not only having both magnitude and direction, it also should follow the vector addition rules. But here the current will not follow any vector addition rules, no. So that is the reason. So therefore, even though it has a magnitude and direction, so therefore it is a scalar quantity. Vector addition means like a parallelogram law or the resolution of this, no, it should be taken place now. So but it is not possible here, no. So therefore, which will not obey the vector addition rules, no. So therefore, current is said to be like a scalar quantity. And what is the device which is used to measure it, no? Therefore, device which is used to measure is nothing but a ammeter. So ammeter is a device which is used to measure it, no? Therefore, measure the current, no? Therefore, ammeter is always should be connected in series in the circuit, no? Series in the circuit, and it should have very low resistance, no? Therefore, it should have low resistance, almost resistance should be equal to 0. So that then only the charges it will be able to flow, then only the current will be able to flow, it will measure more accurately. So ideal ammeter will be having 0 resistance, no. So therefore, here generally ideal will not be there, no. Therefore, so ammeter will be having very low resistance. And how they are connected, no? Compulsory it should be connected in the series in the circuit, no. So not in the parallel, no. Clear? So now therefore, here the amount of charge which is flown, no, q is equals to integral I into dt, or we can write down this is nothing but a area under IT graph. So if you calculate the area under IT graph, no, therefore that will give us like a amount of charge which is flown, no. Therefore, if you charge per unit time it is there, no, therefore charge and time graph is there, no, you have to calculate the slope. You understand, no? So that means, so you can take it as like a slope of charge versus time graph. You understand, no? Clear? So let us see here, if you want to have like a 1 ampere, no, therefore in 1 ampere current, so 1 ampere current, so how much amount of charges will flow or number of electrons it will flow, right? So number of electrons which will flow. So what you can write now, current it can be written as therefore charge per unit time. So charge is nothing but is only electrons will flow. So therefore number of electrons into charge of the electron by time, no. So number of electrons per unit time. So therefore number of electrons flow per second. So therefore it is per second. So number of electrons flow per second, therefore current by E. So current is said to be like 1 ampere, charge of this on 1.6 into 10 the power of minus 19. So taken top, no, 10 the power of 19, 1 by 1.6 is nothing but a, so 0.625 into 10 the power of 19. So therefore 6.25 into 10 the power of 18 electrons per second. So this many number of electrons it will flow, so per second. So then it is said to be like a 1 ampere current it will be flowing. Clear? Right? So therefore we know it, no, already. So if you connect one battery here, no, suppose here the battery is there, no, this is one battery, therefore here it is connected like this. So what is the direction of your current now? Direction of the current it will be taken place from positive to negative, always from higher potential region to lower potential region. So this is said to be higher potential region. This is your current now, current it will be able to flow it now. So in which direction electrons will flow? Electrons will flow in this direction here, no. Clear? So therefore electrons it will be able to flow in this direction, but current it will be able to flow in this direction now. This is said to be like a conventional direction of your current now. That means, so opposite to the direction of your electrons. Suppose you can ask one question now, if an electron is going from east to west, therefore what will be the current direction now? Current direction is from west to east. Or you can write down, therefore some protons are there, or protons are positive charges, it is flowing from east to west, So therefore protons are positively charged, no, therefore current is taken as from east to west only. So but if it is a negative charges are there, opposite to that negative charges, no, direction of the current, no, positive charges are flowing in the direction only the current it will be able to flow. Clear? So this is the flow of our charges, no, you can understand it now. Therefore now let us see, so we will calculate. So one question, very important question, no? Clear? So what will be the current in an hydrogen atom due to one electron, right? So in hydrogen, so hydrogen atom, so therefore this is assumed to be like a Bohr's atomic model, Bohr's atomic model. So what will be the current due to one single electron, current in the first orbit. So you know that in Bohr's atomic model, therefore you should know it now. What will be the radius of the first orbit now? Radius of the first orbit is nothing but 0.53. So angstroms. So will be your, so therefore for first orbit, no, velocity of the electron in first one, no, first electron is nothing but 2.2 into 10 to the power of 6 meters per second. No. This is one velocity of the electron and radius of the orbit is given. No. So then you can calculate the current. How to calculate the current now? See here. So the current, it will be flowing or it will be moving, or the electron is moving in a circular orbit whose radius is r. So what will be the current here now? Current, it will be equal to, so therefore charge per unit time. So here one electron by unit time period, no, we want to calculate the time period. So this is going with the velocity, no. So velocity is equals to, therefore 2 pi r by time period, no. Clear? So time period, it will be equal to 2 pi r by v. Clear? So therefore here we can write down E by, therefore 2 pi r into v. Clear? So this is the formula for the current, no. So we can rewrite it as, no, therefore charge of the electron 1.6 into 10 to the power of minus 19. So velocity of the electron 2.2 into 10 to the power of 6 divided by 2 into 3.14 into radius is nothing but 0.53 into 10 to the power of minus 10. Clear? So therefore here what I can rewrite it as, no, 10 taken top here, no. So 1.6 into 2.2 divided by, so 2 into 3.14 into 0.53 into 10 to the power of minus 9. So therefore it is plus 3, therefore 10 to the power of minus 3. So we will see this calculation, no. Therefore we can do is that for approximation, no, but we will go for accurate value. 1.6 into 2.2. So therefore you can write down 3.52. So actually you can divide it now, this is 1.1. So here 1.6 into 1.1, 1.76 divided by, so therefore 3.14 into 0.53. So 1.66 into 10 to the power of minus 3, nearly 1 milliampere. So still approximately 1.76 divided by 1.66. So 1.06 into 10 to the power of minus 3. Clear? So therefore 1 milliampere you can take it now. Current, it will be equal to 1 milliampere. So this is the current now which is flowing in the electron. So here one concept now, this concept is slightly important now. So this is the formula, if an electron or if any charge, no, so which is moving in a circular orbit, no, therefore this it will be the current. Clear? So now let us see some questions, no, right, related to the current, no. So here right, so current I is given, no, therefore it is current is varying with respect to the time. So therefore flowing through the wire for 2 seconds. Now find the amount of charge flown through this wire. Therefore here current is given as 2 plus 4t. So current can be charge we want to calculate now. Therefore here, So therefore current can be charge is equals to integral I dt. So 0 to 2. So therefore here 0 to 2 current is nothing but a 2 plus 4t into dt. Clear? So 2t integration. No? So integration, therefore 4t square by 2. So 0 to 2. Clear? So therefore here what you can write it now, this is 2. Therefore here you can apply 2 into 2 plus 2 into 4. This is 0. How much now it will be? Therefore here 4 plus 8, therefore 12 coulombs. So therefore amount of charge which is flowing is nothing but a 12 coulombs. Clear? Now we will go for one more question. So therefore here a 20 ampere current flows through the cross section of 20 centimeter square for 20 milliseconds now. Clear? Find out the number of free electrons crossed through that area, right? So number of electrons crossed through that area, so we want to calculate. So here through this area, therefore what is the current here now? 20 ampere. What is this area? Right? So this is your area. So how much time it is given now? Time is given as 20 into 10 to the power of minus 3 seconds. So therefore here current per area, so that is nothing but a current is nothing but a charge per. So therefore area into time, or this charge is nothing but a number of electrons into charge of the electron. So find out the crossing that area. So number of electrons per unit area can be written as, therefore here current into time divided by the charge. Current into time. Current is how much now? 20 ampere. Time is how much now? 20 milliseconds now. So therefore area, a charge of this one of 1.6 into 10 to the power of minus 19. Clear? So this is 4 into 10 to the power of minus 1 into 10 to the power of 19 divided by 1.6, or therefore you can take it as this is your 10, therefore 4 by 16. So 10 into 10 to the power of 19. 4 ones are 4 fours are. So 1 by 4 is nothing but a 0.25 into 10 to the power of 19. So can be written as 2.5 into 10 to the power of 18. So electrons per centimeters per unit area for meter square. So this side area can be cancelled here. We'll see one more question now. So here there is a discharge tube is there, no? There is a discharge tube. 3 into 10 to the power of 18 electrons per second are moving from right to left, and 2 into 10 to the power of 18 positive ions per second moving from left to right. Find the current through the discharge tube now. So therefore there is a one discharge tube now. Therefore here, right, suppose I am taking this is your right. So for you, therefore here right to, therefore this is left. Suppose I assume that. Okay. So therefore here what will happen now? Here electrons are moving from right to left now. Therefore here electrons are going so towards this direction now. Clear? So now next one is what? Therefore here right to left and 2 into 10 to the power of 18 ions per second moving from left to right. Therefore positive charges now. So is going positive charges now. Therefore it is going from this one now. Clear? So obviously if the electrons are going toward this side, means this side it will be your electron current now. This side it will be like a ion current. Clear? So the total current it will be equal to electron current plus ion current now. Therefore current now. So current can be written as number of electrons per unit time into charge of the electron plus number of electrons per unit time, number of charges per unit time. So positive ions means therefore it is also positive charge. So this is n dash by t dash, right. So here number of electrons, this one how much now? Number of electrons per second now. Therefore 3 into 10 the power of 18 into charge of the electron 1.6 into 10 the power of 19, sorry minus 19. So this how much now? 2 into 10 the power of 18 into 1.6 into 10 the power of 19 minus 19. So what I can write it in now, therefore here, so this is 1.6 taken common now, 2 plus 1 3, so sorry 3 plus 2 5 into 10 the power of 18 into 1.6 into 10 the power of minus 19. So this if I take it is now therefore minus 1, so therefore 5 into 1.6 into 10 the power of minus 1. So therefore here 1.6 means 30, therefore this is 8, so minus 1 means 0.8 amperes will be your answer. So what is the direction now? So it is from left to right direction. Clear? So now we will go for one more question now. Right. I think I already discussed this type of question now. So this, an electron is revolving in a circular track of radius is given now, and with the speed is also given, find the current now. Therefore current it will be equal to EV by 2 pi r, we already did in this video only. So electron only, therefore 1.6 into 10 the power of minus 19. So speed is equals to 3.14 into 10 the power of 6 divided by 2 into 3.14 into radius is how much now? 1.6 into 10 the power of minus 2. So 3.14, 1.6, 1.6 get cancelled out now. This taken here now. So taken, therefore 1 by 2 means 0.5 into 10 the power of minus 19 plus 8. So therefore minus 11, therefore here 5 into 10 the power of minus 1, 5 into 10 the power of minus 12 ampere. Clear? So this is your current which is flowing now. Now we will go for another question. Right. So therefore a graph of current carrying wire versus time. Find the amount of charge flowing through the wire within the time interval of time t is equals to 2 seconds to 12 seconds. See, therefore amount of charge, what you can write it now? Charge means what? So amount of charge which is flowing means current into time, therefore nothing but area under this one now. We have to calculate this area plus this area. Clear? So what is this area? This area is nothing but this is 8 minus 2, therefore it is nothing but 6. So this height is nothing but 5. So therefore 30. So 30 coulomb this side now. And this side, so it is looks like a trapezium no, therefore 1 by 2 parallel sides, this is one side, this is one side, parallel sides, sum of parallel sides no, 5, this is 5 plus 10 into height. So therefore height is nothing but 12 minus 8 is nothing but so it is 4. 2s are therefore 15 into 2, therefore 30. So this also 30. So total charge it will be nothing but 60 coulomb. The charge is flowing here. Clear? Right? So now we will go for another question. No? So therefore here a conducting wire is there no, having a material density. So therefore density is how much now? Density is nothing but 20 gram per cc. So atomic mass number, so therefore here, so atomic mass number, so therefore here A is equals to 200. Calculate the number of therefore free electron per unit volume. Number of free electrons per unit volume. Therefore, he is asking now, right, number of free electrons per unit volume, and he told that therefore here each atom will give us like a 1 electron. Therefore, that means, so if we want to calculate it, no, therefore number of free electrons, no, therefore it will be nothing but a number of atoms by, therefore it is volume. So number of atoms, what you can write it now, number of atoms is nothing but a, so we can rewrite it as, therefore suppose here number of atoms can be calculated as like a number of moles into, therefore their Avogadro number, right. So therefore here number of atoms, no, so can be taken as like a, so number of moles into, therefore Avogadro number divided by volume. Clear? So number of moles can be calculated as, mass of the given atom, divided by gram molecular weight. So that means number of moles can be written as mass of the, this one, no, mass into number of Avogadro number divided by gram molecular weight, here given atomic mass number, therefore it is given as, so therefore mass number it is given as 200. This is 200 means 200 grams, no, 200 into 10 to the power of minus 3 kg. So therefore into volume. So mass of each, right, so mass atom into number of atoms, no, we can rewrite it as like a, so therefore here density, so therefore your density into number of Avogadro number by 200 into 10 to the power of minus 3. So density is given as like how much now, 20 into 10 to the power of, okay, so gram per cc, so can be written as 1000 by 10 to the power of minus 6 into Avogadro number 6.023 into 10 to the power of 23 divided by, so 2 into 10 to the power of minus 1. So therefore here you can write it as 10 to the power of 9 minus 3, sorry, this is minus 3 grams, no. So 10 to the power of, what you can write it now, 3. So 20 into, so 10 to the power of 3 into 6.023 into 10 to the power of 23 divided by 2 into 10 to the power of minus 1. So taken top, no, therefore this is 155. So this will get cancelled out, no, therefore 6.023 into 10 to the power of 5. So 5 means 28. So 6.023 into 10 to the power of 28 electrons per unit volume will be your answer now. Clear? So slightly, right, some chemistry concepts, no, therefore we can get it here. Clear? Right, we'll go for one more question. Right, so this is one short video for the basics level of current, no. So therefore next class we will discuss drift velocity and the current, right, calculation, and from that one now we are going to derive Ohm's law and resistance formula. All this one now we will discuss in the next class. So thank you for watching. Please subscribe to my channel now.